Hi everyone, we're Crocodile Communications. I think we're the last to go, and we'll try to keep it snappy. I'm Crocodile John. I'm the... Oh, someone laughed. I didn't think they would.
Dean, I saw him groan. Don't mark us down for that, please.
No, not for that. Okay, I'm Crocodile John. I'm the co-founder of Crocodile, and this is Peter. Crocodile Peter, the technical director of Crocodile. So we're in the business of hugely resilient and hugely scalable platforms for rich communications. And by platforms, I mean that we provide systems, we provide network capabilities, and we provide SDK for our users. What do you need to know about the company? We have a few principles. We very strongly believe in open standards, we use them, and we contribute to them. We believe in open source. We use open source, and we try to contribute to open source as much as we can. We believe in interoperability. We believe that services using a WebRTC and users should be able to talk to each other. We believe in a free internet, freedom of speech, not as in free beer, although most services which will be running on our platforms will be free to the users. And we want to enable more and better communications. If we have better communications, we add value. If we add value, we can make some money out of it. What we're going to demonstrate here now is an application that we wrote to show off our underlying platform capabilities. Actually, this one's dedicated to you, Dean. I thought we should get some marks just for including the join logo at the WebRTC conference. So for those of you who don't know, RCS stands for Rich Communications Suite. It's a set of services defined by the GSMA. It's the GSMA's way of helping the mobile industry to fight back against over-the-top players. So we thought it would be fun to implement an RCS client as a WebRTC web app. So what we're going to demonstrate today is voice call, video call, presence, instant messaging, and file transfer. So why did we do this? First of all, we wanted to showcase our platform, and secondly, seriously, our existing RCS clients are very, very expensive to develop for all the different platforms, to maintain and to brand them for particular users. So what have we actually done in the last 3 months? We've authored the MSRP draft, the draft for MSRP over WebSockets. We've added both SIP over WebSockets and MEM MSRP sockets to the Camellio open source, and we've implemented it within our own Crocodile Supernode product. We've implemented the MSRP over WebSockets client stack in JavaScript, and we've developed the RCS client, which you're going to see. So just to show really what's in the network behind the demo, you'll see the client. We'll be using WebRTC to channel the voice and video between the clients. But very importantly, we'll be using SIP and MLC over WebSockets to carry the signaling to the central servers, which is our Supernode, which is based in a data center in the UK. And the Supernode, in this case, is acting as an edge proxy registrar, stun and turn server, and MSRP relay. So that's what's under the bonnet. So I'm going to hand over to Peter to actually make the demo.
Okay. First of all, is this working? Okay, so as John said, we've got our rich communications client. This is using SIP over WebSockets for session establishment. We use MSRP over WebSocket for file transfer and for instant messaging. Now, the reason we're doing this, rather than something a bit more proprietary, is simply that interoperability is important. Yes, a lot of services are islands, but one of the things you don't want to do is use a protocol that forces you to be an island forever. So by using standardized protocols, you can take advantage of years and years of experience in scaling and resiliency and quality of service. You give yourself the option to interoperate. So we've prepared our SDK, which wrappers these stacks in JavaScript. So you can then implement your own business logic on top of it without needing to understand the real-time communications, without needing to understand the signaling. And why is it an advantage to use this technology? Well, regulatory issues are important, lawful interception, billing, all of these things, absolutely essential. And by using standard technology within the network, that is much, much easier. So, as you can see, when I've logged in, we have an address book and presence capability, and John is online. Sorry. Hello. So I'm going to start an instant messaging session with John. And this establishes an MSRP over WebSocket session with John. We have it's composing. You saw pretty instantly as John started typing there. We got notification of that. And now we've chatted a bit. I'll call him. And you can now see me talking to John. In a moment, his HP webcam will wake up. It usually takes a few seconds, and we will actually see him. The audio is actually turned off because I didn't want nasty feedback. And so we have this. And John is now going to send me a file. He needs to share a file with me. And yes. So I accept this file transfer request. Comes across to my computer fairly seamlessly. It's downloaded into the browser's local cache. That's a security measure, but after that I can just save it as if a file. It copies it out of the cache into my file system, and I can open the file. The reason we're doing this, MSRP rather than data channel, this interoperates. This is already out there. You don't need another WebRTC client to talk to. It will work with other standard clients that are out there. For media interworking, we are working with, we do hope that clients will implement all of the extensions that the WebRTC people are rightfully mandating. But in the meantime, we're working with a media server company so that should we have any issues establishing a call directly, because we have control over the network equipment, we can pretty seamlessly capture that problem and redirect the call through a media server. And hopefully over time, that media server will be used less and less, but then we can start doing some very clever network conferencing and other things using those resources. So I'll just finish off by saying that, this is our client on top of our SDK. We could have done click-to-call. We could have done simple conferencing app. We decided to do this because we wanted to show that by using WebRTC, rather than just using WebRTC on its own, by combining it with other technologies, you can actually achieve something quite different. And that's what we're trying to do here, to demonstrate that this is probably more fully featured than most SIP clients that are out there right now. And this was very rapidly developed, very easy to develop. And we think that WebRTC as a technology is going to enable this. I'm done.